There we go.
Beautiful.
So how are things going today?
Well, I'm still having to deal with a computer crash.
No.
That's no fun.
No, it's not at all.
Yeah.
Fortunately, I was backed up, and besides, all my operating files were on a different physical hard drive. So I've got them, but reconstructing the other stuff has been a little bit of a problem. And I had lost my Visio installation disk in the move down here. So I had to suck it up and buy that again, and I hated that.
Oh, wow.
I think that's the only thing I got to rebuy.
That's still a Microsoft product?
Yes, unfortunately.
Yeah.
Is this your regular computer?
Yeah, my main office computer.
What do you need to rebuy?
Visio,
Oh, Visio.
what I do all my drawings in.
Oh, wow, yeah. Sorry to hear that.
Yeah, I wasn't happy about that one, but could have been worse. At least all of my operating files were on a different hard drive, and besides that, I was 100% backed up. Oh, and then I had backed up the entire computer, only using a Western Digital external drive, only to find out that a few years ago, Western Digital deprecated the backup software, and what they replaced it with is incompatible.
That's unfortunate too.
That really made me mad. So my new backup strategy when I get it fixed will not include Western Digital.
No, I think what I'm doing right now is I have all my important documents. I try to have both in the cloud using either OneDrive or Google Drive. And then I also, at least for my Google Drive account, I have that also backed up to a local hard disk. But I need to do that for the OneDrive too.
Yeah, I do that for my financial records, but the others I just backed up to the local drive. But I'll be coming up with a new backup strategy that sounds more like yours.
That sounds good. Yeah, and something that doesn't rely necessarily on this proprietary backup software for recovery.
Yeah, that really steamed me when I realized that.
Yeah. So is anyone running the meeting this morning? I know Rachel's out right now because she has exams.
I'll take a stab at it just because I've got a couple of agenda items.
Okay, and I can certainly do it too. So either way, you can go ahead first. I definitely want to hear from John over there. And then we have quite a few of the New England Grape Group people on today. So should definitely hear from them. And then, Paul and Jim. I can, yeah.
Do I have audio?
Yes,
Yes, you do,
yes,
Bob.
Bob.
Okay, thank you. I just wasn't sure. I'm in North Carolina. I'm using an iPad, and me and it don't get along very well.
So yeah, go ahead, Nathaniel. If you got ideas on what you want to cover, go for it.
Why don't we start with John? How are you doing, John?
Doing
You've
all right.
had lots of excitement this week, haven't you?
Yeah. I soldered down the quad bottom-sided soldered part to one of the proto boards, and it actually worked first try.
Whoa.
I figured out that the
Yeah.
board manufacturer left out the inner 2 layers on my 4-layer board.
Oh.
Oh,
Oh, great.
Yeah.
that's not good.
Yeah. Fortunately, it was only 5 boards from them. Those are the ones that left off the silk screen too. So they're on my naughty list. They're not going to get any more orders from me. But I got the switch mode power supply working. It's working extremely well. I took it up to 3 amps at 5 volts, and it didn't droop more than like 3 millivolts. So it's rock solid. It should handle the solid state drive, peak currents, and all that kind of stuff. So moving forward with that. And yesterday I got the second set of boards in from JLB PCB, and I'm going to build those up and hopefully get those to Bob and Bill within, I'm hoping the next week. So, but from, let's see the calendar there, I'm not seeing it. I think the last 2 weeks of May, I'm going to be out of town on vacation. So I want to get something in their hands to play with.
Nice. That sounds really good.
But we're looking pretty good. We got the major parts crisis for building the RF boards resolved. Those parts should be arriving, I think, tomorrow. But other than that, we're moving along. I think Bill ran into a bit of an issue with programming the 5351. It didn't seem to be liking the input we were giving it, or he was giving it, so we have to resolve that. But other than technical issues, I think that's the only big one on my plate right now.
So do you think we're still on track for doing the distribution of these Grape 2s instead of doing the Grape 1, then Grape 2 distribution?
Once the hardware is verified, it's really going to fall into how fast we can pull together getting all of the OS stuff done with Bill and Bob. I mean, they obviously can't do anything until they have hardware, but they've got a fair amount of work to do yet. So I think we're on track. Depends on what you're calling schedule, though. I'm sort of thinking sometime August should be ready to distribute, but it all depends on how fast we get through this file saving creation and all that kind of stuff. So
that sounds good.
I think Bill could probably speak to at least his part. He's making great progress, but we still have some. I mean, he's got some basic functionality going, which is huge because that means everything's tying together. But we do have.
We've got the command interpreter running on the Pico and stable, so that it can receive commands from the Raspberry Pi. And I've got the clock, the SI 5351 clock programming done. We're having, a bit of an issue or discrepancy between what Bob sees and what I see on the 8 megahertz clock input to that chip, and whether we're getting the right generated frequencies out of that. But I think Bob and I can resolve that. And the next thing to do is to go ahead and turn on the data simulator so that we can get very good numbers on the transfer rate between the Pi and the Pico. And then I think the next job is to turn on the A to D enable bits, which should be, it's pretty easy, straightforward. Always seems easy,
I try to make it easy.
I'll get that back to John so he can start to test the A to D conversion.
I'm starting to look into board houses local for manufacturing the boards. There's a couple of them I have to follow up with and figure out what they want for manufacturability for their CAM process. What else? There's one other thing. What was it? Oh, well, it'll come to me. Just got a lot of irons in the fire here.
Yeah.
Today's the last day of finals, so students are starting to disappear, so it's starting to become a little calmer, but
yeah, definitely. Bill, are you going to Dayton?
No, I'm not.
Okay.
I can't make it. But
yeah, so Kung is going to be starting on this project. He's going to Dayton. He'll be meeting with Bill Engelke out there, but Kung's be working full time on this project starting pretty much right after finals and exam finals in Dayton. And so I told him that his priority for this summer is going to be making sure that helping to get the data collection from the Grape up to Bill Engelke's servers. So his job right now is to talk to Bill Engelke and figure out what that architecture should look like on his end. You know, maybe I should also have him start reaching out to either to you, Bill, or to you, John, to try to come up with that requirements document to figure all those things out. But he's going to be, I think, very helpful in helping to make sure that code does what it needs to do. And Kung's very competent, and he's you know, he's very familiar with WWV and our project since he's done a few projects with it over the past couple of years. So I think he's going to be very helpful with this.
Great to have that resource. That's
yeah,
Nathaniel.
Yeah. So you know, Kung's not here right now because again, it's finals and he's a graduating senior. So and he's trying to get through that. But once he gets through that, you know, as I said, he'll be at Dayton next week, and then maybe we can start exchanging emails, and that way you can be in the loop with him, and we can figure out what the right plan is going forward there.
Super.
Okay.
Yeah, the other thing I've got going on in the background is I have David Castan looking into doing the 1 pulse per second calculation like it was done in FLDigi.
Mm-hmm.
And if we can do that as a background task on the Raspberry Pi, we can actually still be submitting the 1 day's files up to the server like Christina is using now. Because right
That's
now,
really
we don't really have a path of any of the data going up, but it sounds like Hung or whatever his name is going to be working on that.
Right. Yes.
So
Hung will be working on that. But yeah, I think that's a really good thing for David to be doing. I think that's going to be a very useful thing. Because I do think it is. I do think it is important that we are able to maintain that sort of backward compatibility and be able to go from the digital RF to the same FLDigi sort of algorithm.
Well, the thing that makes it simple is you've got 1 second windows of data.
Yes.
It's a finite data set. So he just has to sift through 8,000 samples on each one, run his algorithm, and come up with a number.
It shouldn't be that computationally intensive.
And he's got a trick where he can actually focus where the FFT computations is done around the bins.
Yeah.
And it's a phase thing. David, there you
go.
Yeah, I'm listening. Sorry. For what it's worth, it's not an FFT computation. This one is time domain. It's not a frequency domain computation.
Okay. So
I remember you saying that.
Yeah, the modem in FLDigi that's marked FMT, that one is a frequency domain measurement. The one that's marked frequency measurement isn't.
Anyway, I've got David working on that. Better mind than I.
Yeah, I think that's a really good thing to do. So David, are you doing that? Like, how are you implementing that? You're trying to pull the code?
Oh God, I haven't implemented anything yet. I'm trying to figure out the C++ module from FLDigi. And they did a good job writing it. I'm not saying otherwise, but it's complicated and it has many, many dependencies. So with any luck at all, we can use their code, but I don't know that yet.
Yeah, I mean, that would be ideal because you'd want it to be the same algorithm.
I agree.
So yeah, if the way I see this, the way I see it working in my head is you have the Grape is reading this spectrum data using, you know, the IQ data, and then the IQ data stream, however it's stored, when I say IQ, the complex sampling that you're doing, John?
It's not complex.
Right. His isn't.
Mine is.
This is low IF, but it's not IQ.
Okay. So you're just having regularly sampled data. Okay. So you have your regularly sampled data that whatever it is, you have the raw data go in. It goes exactly through FLDigi's algorithm, just basically the same code, and then outputs, you know, exactly what it did from FLDigi.
And we're following the same file structure and all that kind of stuff.
Yeah.
Also, the file structure that I've defined also applies to the magnetometer data, because the data will have the full header stamp with all the information about the node, which I don't believe is being done with the existing one. I'm not sure how the station information is being tracked in the file for the magnetometer data.
Mhm.
I've got the file structure already figured out, and I was going to start uploading that as well because I've got that all defined in my file document.
Mhm.
I'll have to work with, I guess, Bill, because it really doesn't have anything to do. I'm not sure he's even collecting the magnetometer data. I think isn't that going to someplace else right now?
You're talking to this Bill.
Not that Bill, Bill Engelke.
Sorry, Bill. Yeah.
Wrong Bill, sorry.
Yeah.
I don't see Bill.
Yeah, I don't see him online right now.
Yeah, because he shifted.
Let me take care of it.
Oh, go ahead, John. Keep going.
Okay. Yeah, we're working on that as well because that's being also captured by the Raspberry Pi on a continuous 1 second per sample data stream.
Yeah. Yeah.
So
that sounds very good.
Pieces here. So ideally, I'd be uploading from the Grape 2. It would be 3 separate files for the 3 frequencies and then 1 file for the magnetometer data every day.
Yeah.
And that's the plan.
Okay. That sounds really good.
And I'm looking in, you suggested, I believe, a 2 terabyte drive. So I'm probably not going to go any smaller than that, but I'm going to have to price that stuff out and figure out what we're doing on that. But
yeah, I'm sure those prices have adjusted since we made the original budget.
Yeah.
Not necessarily favorably.
Correct.
But you don't know until you find out.
The trigger, great. I did get the cables ordered yesterday from Adafruit. They had a 6-inch 40-pin ribbon cable for $2.95 each, which is cheaper than buying just the headers, let alone the wire headers and assembly. And that ties the Grape 2 into the Raspberry Pi. So
that's great.
We're making progress.
That's really nice.
Yeah, and I'm hoping, like I say, I want to get something in Bill and Bob's hands before I go on vacation. So I'm pushing really hard now to see if I can have lightning strike 3 times on this surface mount part. It is a challenge. I mean, it's all underside part. I can't see any of it, but I'm soldering, and you get 1 shot at it.
Oh boy!
So far, I'm 1 for 1. I'm hoping to be 4 for 4. We'll see what happens.
Yeah, that makes sense. All right, that sounds like a good report.
Yeah, we're making progress. It's I'm a little concerned about Bill's finding about the 50-51, but I certainly have the analog tools on my bench to be able to ascertain that once I get the 8 megahertz coming out of the U-Blocks thing on my original prototype, which did not include the Raspberry Pi as part of the architecture, it was all based on just the Pico. I'm going to try and massage the code a little bit so I can program the 8 megahertz to come out of the U-Blocks and feed my data engine, and then have the Pico start the engine up, and then also program, actually the Pico will be programming on the same port, the 50-51s, which then with the 8 megahertz input, I can then ascertain and figure out what's going on with Bill's problem. So
yeah,
that's really the big hardware issue on my plate. Otherwise, other than getting these protos built up. So I think Bill's got enough code for me to be able to be dangerous. So we're working on that.
Yeah, I'll push it up to GitHub today. So
okay,
have it. And then we're having our 1 o'clock this afternoon, right? Or not?
We got a 1 o'clock on Friday.
Oh, I think it's
Today's Thursday.
Oh, sorry. I thought it was Sunday. Sorry. I mean Monday. I'm confused.
Welcome to the club.
Too many late nights. Okay.
I'm glad I'm not the only one that does that.
Back to that.
Yeah, back to that.
Thank you. That sounds like a good report. Let's see. I do want to recognize that Veronica Romanik is on here, and I'd like to. I think we should hear from her first because she's busy trying to do a Spanish portfolio in addition to like a million other things. But we'll hear from Veronica, And then I want to hear from Gary regarding where we are on finding locations for stations. So let's hear from, so first of all, I'd like to congratulate Veronica. She successfully defended her bachelor's thesis in physics. So Scranton actually makes physics students do bachelor thesis and presentations. And so she's going to give us the 5-minute version of her results.
Oh, cool.
Let me share my screen here. Okay. So I'll probably just skip around through the slides that I used for my defense here, but I am assuming that everyone is familiar with TIDs, so I won't go over them too much, but I will just say that the research I've been doing has been specifically looking at medium scale TIDs or MSTIDs, which is characterized by wavelengths of 50 to 500 kilometers in periods of about 15 to 60 minutes. And I've been studying them using the Grape system designed by Hamside. So let's see. So again, we're monitoring the 10 megahertz transmission from WWV using, in my case, the Grape that Dr. Purcell has near Scranton, Pennsylvania. And this is a map of the path that the radio wave takes. And I am making the assumption that the wave is interacting about halfway between the transmitter and receiver, which is around Chicago. So as you know, the Grape collects data in 1 second intervals, and I'm just working with the frequency data. I'm not working with the voltage data at all. And so I am applying a filter to it. I'm specifically looking for periods of 15 to 60 minutes because that is what we would expect to see from MSTIDs. And to do that, I am first converting the data to the central time zone because that is the point that we're assuming the radio wave is interacting with the ionosphere. So that would be the time zone in the region where we're actually getting this data from. And so what I do is I break down the data into seasons, and I define the seasons based on the summer solstice and each prospective solstice and equinox, and I take a month before and a month after that data. And then I do day by day, I generate these Doppler shift plots, and you can see how plots with stronger amplitudes generate brighter yellow spots on the plot on top, which just means that there's a stronger power spectral density correlating with that oscillation. And so because we're filtering the data to look for these specific periods, it's very likely that these oscillations are from MSTIDs. And so what I do is I take a season's worth of that data and I average it to get, for example, the plot on top. So here what you're looking at on the top is an average of all the PSD values. The middle is just a specific day to show how the Doppler shifted wave on the bottom correlates with the brighter spot, and then how we're taking a month, the season's worth of these middle plots to get this plot on top. And so I did this for each season. At first, I just looked at 2021, and these are the results that we had. And then I also applied it to 2022 to get these results on the right here. And so what we're seeing is increased activity around the sunrise and sunset. So this curvy line on top is the solar elevation angle, and this flat line across is the nautical zero. And so we're assuming sunrise and sunset are relatively around the point where this flat line intersects with the rounded line. And you see that in both cases, there is more, there are brighter PSD values around the points where the sun is rising and setting. We did notice that in some cases, the spots are brighter and duller in the different years of seasons. And my thoughts initially on this are that it's because I am averaging all of the days. And so if there's a day that has a really strong TID or a really weak TID, that could be kind of dominating my data. So one thing that I'm going to do in the very near future is I'm going to set these bars all to the same value so we can see like how the intensity compares when they're all set to the same value. I meant to do that before today, but I'm sorry, I haven't had a chance yet. But so this is basically the results we're seeing. And one of the thoughts for why we're seeing it around sunrise and sunset is likely due to the ionization of the ionosphere, because as the sun is shining and ionizing the ionosphere, there's a lot of movement likely going on, and same with when it's recombining. This is something that is just a thought. It's not, we have to look into it further, of course, but that's my initial thoughts from the results that we're seeing. So some assumptions that I made is that there's just one hop between the transmitter and receiver. Devin Deal, who is a student at Scranton, he generated these plots for me, and you can see in each case, this is taken at this the left-hand side is the sunrise time and the right-hand side is the sunset time for each respective solstice and equinox. And you can see that in each case, there's one hop between the transmitter and receiver, which is around, I believe, somewhere around 2,500 kilometers, give or take. And so we made the assumption that there's one hop. So the data we're analyzing is from the region of the ionosphere that we're assuming the wave interacts with. There weren't many limitations in this particular project because Dr. Purcell had the Grape on and running all the time. So in the case that I was looking at a different Grape, I would have to consider that some days if somebody were to disconnect the antenna from the Grape to transmit or something, like in my case, if I want to transmit, I have to disconnect the antenna from my Grape, and so I wouldn't be collecting data for that time. But that wasn't really a problem with the data from Dr. Purcell's Grape. And then another limitation is that I've only applied this method to one specific Grape, but in the future, I could expand my method to look at data from different Grapes or even different frequencies potentially. And then again, in the future, we can work to analyze these results better to get maybe more quantitative results as opposed to the qualitative results that I have now. So these are my conclusions. I'm looking for MSTIDs, working with Grape data. I'm doing this by looking at the power spectral density of the Doppler shifted 10 megahertz wave from WWV. I'm seeing increased activity around sunrise and sunset, which is consistent with what we would expect to see with MSTIDs, which are also seen through the local night. And there does appear to be seasonal variations in activity. So my acknowledgements. A lot of you in this call are listed here for your contributions and your help with everything I've been doing. So, all right, thank you.
Very nicely done. Very nicely done.
Thank you.
Mm-hmm.
And you got that all from a Grape? now you're scaring me.
I think this is really, really, really nice work.
It is.
Yeah. And I think, you know, certainly without Case Western's dedication and work to this and the other volunteers, this would not have been possible. So we're very grateful. And I think this has been a really fun collaboration. And I think what Veronica has done, I'm very excited because I think Veronica's work here is not the end of her bachelor's degree, but the beginning of a long and fruitful continuation of this project on many fronts, because I think the techniques that she's showing here like the software she's developed in these plots. I could see Rachel Bodeker making use of in her work. I could see this sort of thing being developed into a data product that we, post that we have on the Personal Space Weather Station website. And now that Veronica's going to Virginia Tech and working in the SuperDarn laboratory, I think this sets her up very well for doing comparisons of the Grape observations with the SuperDarn observations, which is really nice because SuperDarn is a very well recognized, professional grade space physics instrument. And, it's really important with these things to be able to cross calibrate and, look at the data, they're, as Christina wrote in her papers, they're complementary data sets. So I think, Veronica is very well set up to do some of these comparisons. And she did this analysis just using, my Grape, but she has a code written that she could really do the analysis on any Grape. And, we haven't released it like open source per se, but I don't think Veronica probably would not have any objection to sharing the code with other Grape operators who would like to do similar analysis on their stations. So.
Especially if the code is easily run. I don't know what you wrote it in, but is it in a compiled language that's an object that runs, or you have to have some type of interpreter?
It's in Python.
Okay, it's in Python, so that's really
it's actually Jupyter Notebook.
Yeah.
Okay. So with that and a little bit of verbiage on how to input your data, that could be a huge contribution to this whole project.
Yeah, for sure. I've actually been cleaning up my code a lot lately because I'm going to be including it in my thesis.
I know that feeling.
Yes. So once I have it all cleaned with nice comments and like directions and stuff, I can put it on my GitHub and make it accessible to everyone.
Fantastic.
And a good test and something that probably help her out is if we had some volunteers who are collecting Grape data, if they wanted to try to run her code on their data and see what results they get. And then in the process, they'll probably find ways to, suggestions to Veronica on how to improve her documentation or, different aspects about the code that would really help her out and improve the code base for everyone to make it more usable.
Do you plan on taking this further, Veronica, with your work at SuperDarn, or?
It's definitely something I'm considering.
Okay.
I haven't worked much with the SuperDarn data, so my plan is to start grad school and maybe get oriented and then
sure.
work from there. But I definitely think, like Dr. Purcell was saying, this is very possible for me to keep working on this in the future.
Yeah.
It's definitely something I'd be very interested in doing as well.
I think what's nice too is one of the ways we're kicking off our summer is I'm working with the SuperDarn people at Virginia Tech, and we're going to be having a SuperDarn Space Weather Summer School for the week of June 11th. And so I'm going to take a bunch of Scranton students down, including Veronica, who will then ceremoniously transition to being a Virginia Tech student. And then Rachel Bodeker is going to come too. So we're going to bring her down, and the students, and then there's going to be a bunch of Virginia Tech undergrads and students in the program as well. And we're going to spend the week looking at what SuperDarn is, how to access SuperDarn, and how to plot it using Python. So all of the students, Veronica, Rachel, Bodeker, our students, they'll all have a chance to kind of get their hands dirty with the SuperDarn, in a 1 week intensive workshop. So I think that will also really help both, Veronica's project. I think it'll help Rachel out too with the work that she has to do here as well.
I'm very excited.
It's going to be a lot of fun. Any other questions for Veronica?
Veronica, what level of the ionosphere is that F layer, you think, or?
Yeah, I think it's likely the F layer. Let me see, I have a diagram here.
Well, why don't you go to your ray trace plots, Veronica?
There you go. Yeah, so it's like refracting around like 200-ish kilometers, give or take. Yeah.
Yeah, I think I think Steve Serwin's work has given a little more insight into that. He's shown that the E region tends to be a little bit more stable regarding like these wave-like types of disturbances. Right. So I would think it's likely the F layer. I think to better diagnose that, there's a number of things we can do. We can do better modeling. These models really that we're showing, they really are just cartoons, but we have, Devin Deal is working on improving the modeling capabilities that we have. What else do we have? So there's that. I think when we get the digital RF data going and we can see the full spectrum, it's again going to be easier to diagnose is it E region or F region looking at digital RF and comparing it with this. So I think there's a number of things that need to go on there. But yeah, I think this is really, really nice work, Veronica. So I'm super excited about this.
Thank you. So am I.
You're welcome. Actually, I'd like to show one thing really quickly, relating to the eclipse. Some of you have seen this already, but I think most of you have not. And that is Joe Cuba. I gave Joe Cuba the tracks for the annular eclipse this October, and then Joe took that and he ran a SAMI 3 prediction for the October eclipse. So we now have a prediction of what the ionosphere will look like for the October eclipse. And so I can show that to you now. Give me 1 second here. Okay. So this is a presentation that Joe gave to Rachel Bodeker, Devin Deal, and myself on Monday. So this is like hot off the presses. Here are the calculations from my eclipse calculator showing the path. And one thing that we've picked up from this is look how much the eclipse path is going over both Canada and South America. So I was talking to Gary, and we should really talk about this more this afternoon, Gary. Talking about expanding the solar eclipse QSO party to all of the American continents, so both North America and South America. Then here's Joe Cuba's SAMI 3 prediction. Let's see if I can do. I want to show views full screen. Okay, maybe Control L. There we go. Okay, good. So on top here, this is the SAMI 3 predictions of total electron content without the eclipse. And on the bottom is the predictions of total electron content with the eclipse. So to actually see the eclipse, you're going to want to look right here in the United States. You're going to see a little depletion move over there. So here we go. There you're starting to see the effects of the eclipse right there. So this is the annular eclipse this October. Let me run that one more time. And now you can try and compare what's going on here, which this is without the eclipse, to what's going on over here, which is with the eclipse. So Joe did another version of this. where this is one minus the other. So this will show very dramatically where the eclipse is happening. So this is a differential plot where he took the bottom minus the top. So you can see the plasma depletion.
Interesting.
Yeah. So as I said, this is now delta total electron content. So these are things we can easily compare right to the GPS total electron content measurements. It's a little harder for amateur radio operators to really understand how this might affect the radio signals. I mean, very, very simply, you can basically say, okay, the region that is going through here is, you know, we've been saying night-like, but I would say it's probably more like dusk-like. If you actually, Devin plotted night versus the eclipse the other day, and you can see night is much more depleted than the eclipse. But so you can imagine maybe like dusk-like conditions during the annular eclipse.
It's almost like you'd have gray line conditions between two spots.
Yeah, but do you get like gray circle conditions? Or I mean,
Right,
it's not
right.
a line. So I'm not exactly sure what this means. I think more work would need to be done to put this in a format that would actually be usable to really say, okay, how this might affect amateur radio conditions. So of course, one way to do that is to do the ray tracing plots. Another way might be, you know, Andrew Rodland, he runs prop.kc2g.com, I believe. He'll be at Dayton Hamvention, and it might be possible to have him run this through his software, because then it could give you like maps of maximum usable frequency and things like that, perhaps in real time. I think one question we have to ask ourselves is, for the solar eclipse QSO party, do we want that information to be available in real time to people? Because that might affect people's operating strategies. Maybe we do, maybe we don't. We'll save that for debate for later. The other thing Joe wanted to point out is that at the end of the annular eclipse in the equatorial region, you get this feature showing up, this feature right here. This feature showing up over here. This is an equatorial plasma bubble. So there's a depletion in electron density over here and an increase in electron density over there. And this plasma bubble does not show up when you don't have the eclipse. And that Joe thought was very interesting. So I'm going to play this again, and you can watch towards the end of this. You'll see the plasma bubble show up here, but not there. And this was a finding that really surprised Joe when he looked at this.
Any idea why that would happen so far away from the eclipse path?
He said he's still thinking about that. But
oh yeah,
he's, you know, there it is.
And it looks like a bow wave in front of the plasma.
Yeah. So one thing he noted too is that, you know, equatorial bubbles, they typically form, you know, in the evening at dusk in the equatorial region. So you get, so with the eclipse, you kind of get that dusk condition a little bit sooner than you normally do, or maybe that seeds something. But he said that this is something that shows up with the annular eclipse going on the north to south path that you don't see with the total eclipse going on the south to north path. So he was suggesting there's a satellite mission called GOLD, which he believes, you know, it's monitoring the ionosphere, I think in situ. Do you remember, David, is it in situ or is it?
I've always said in situ, but what do I know?
No. The other David, David McGaw. I can't remember what GOLD's orbit is, how it's sensing the ionosphere.
I don't know.
Okay. Anyway, there's this NASA mission called GOLD that's studying the ionosphere in the equatorial region, and Joe says we should be able to see it. GOLD should be able to observe this, and it's also something that might be interesting if you see the same conditions in the QSO party.
Is GOLD low Earth orbit?
I don't remember. I have to go look that up. Got to do my homework. So anyway, these are the eclipse predictions for the ionosphere so far. So I'm very happy that we have these, and Joe said I could show these at the Hamvention this coming week.
Well, Nathaniel, apropos that, I've been working on finding an amateur in Austin or a club that can set up beaconing along the path of the April total solar eclipse with us in Cleveland. As I think I mentioned to you, and maybe others here haven't heard, because I'm really fishing for ideas here. The eclipse path is roughly along the Great Circle path between Austin and Cleveland. So having amateur stations beaconing back and forth between those two cities would be a different experiment from what we've been planning. Everything.
Have you looked at or listened to Steve Serwin's plans?
I haven't talked with him about this.
Because Steve Serwin has a whole thing called the time difference of arrival experiment that he's planning on coordinating, which is basically stations beaconing back and forth and actually sending a waveform, a version of Christina's waveform. And it sounds like what you want to do would be well aligned with what Steve's trying to do.
All right, let me check with him.
And we have that information. That information is on the HamSci website, so it's already like written out. So
okay, I didn't know that. So good, thanks. Yeah. Along those lines, then, from what you're describing, for the October eclipse, the roughly Austin to Portland, Oregon path has similar characteristics, and from what you're showing here, the path maybe Central South America to Mexico City is about the same thing for the electron depletion path, and from Southwestern Europe into Northern South America might cover the electron enhancement path. How many correspondents do we have?
How many correspondents do we have down in?
Like, say, central Brazil to Mexico City. That's the path that's of interest in your electron depletion path.
Like how many hams do we have?
Yeah, and the one from, it looks like roughly southern Spain into northeastern South America is the one for the electron enhancement path.
So one thing, we haven't really reached out too much to the South American people yet. We just came across this idea like on Monday.
Nathaniel, I have two correspondents that are interested in working on exactly this. One in San Jose, Costa Rica, and a second one in Panama City. And they're both going to be equipped with both transmit and receive equipment during the eclipse event. So they're right on the path of totality or annularity. So I think one of them sent an email but did not receive any response asking if his data would be observed and recorded. So, I'll forward that again. John TI for JWC. There's also Alejandro in Panama City. So these are both people who are already in operation with GPS stabilized receivers and soon GPS stabilized transmitters.
That's excellent. Can you also send that information, forward that to Gary as well, please?
Yes.
Thanks. Yeah, I'm sorry I missed that email. It's everything I can do to keep up with it. But
I understand.
That would be very, very good, because Gary and I were talking. I think in order to make this work, I think there are a couple of options. One is basically just to, leave the rules as they are, which actually I think the rules might be fine the way they are. But basically just say, okay, whoever participates can. But the other thing we might have to do is we may need to get, someone else to help be the evangelist for doing the international work, because this is starting to get complicated. I also know, and I think another person I should reach out to definitely is Jim Spann. Jim Spann is one of the NASA program officers, and he's actually a big supporter of our work. And he is a big supporter of the citizen science efforts. He also is, I forget if he's PI or if he's working on this satellite mission called SPORT, which involves looking at equatorial plasma bubbles, I think, and scintillations. I may not have all my details right, but he is involved in that, and I think he is working with Brazilian collaborators as well. So I think maybe Rob, if you want to reach out to your contacts on the amateur side, Gary, if you have any ideas for contacts on the amateur side, that would be good. I think possibly reaching out to Angel Vasquez, WP3R, because he's, the Arecibo ham. He might have some, and he is very well known in the community. He might be very interested in helping to interface with Spanish speaking hams. And then I'll reach out to Jim Spann on the NASA side and see, what sort of things we can get going with NASA that way. So I think that's very exciting. So yeah, and then David Kasdan on the HamSci website, if you go here to the main page and you click Festivals of Eclipse Ionospheric Science, if you scroll down, you can see HamSci Festival of Eclipse Ionospheric Science.
I looked for it and couldn't find it. That's it. Good.
Research events, time delay of arrival event. And you click there. This explains what Steve Serwin's planning on doing. And
I'll send him a note and ask for more specifics too. I'm not sure that those frequencies are going to be the best for all of these.
Right. Well, why don't you touch base with him? Because I think this is very similar to what you want to do. So I think you should at least check with him.
Good.
Yeah. And I think this is also using the notebooks that Christina made up. So I think Christina is the one who wrote the code that's generating the customized transmission code.
I think in the second paragraph, there's a link to the paper Steve wrote that details this process far more than I did on the front of this page.
Yeah. Yes. And Christina's writing some stuff in the chat. She says that she started the notebook job and Aiden finished it. So thank you to both of you. And then for the 2020 Eclipse Festivals, she also published pages on taking Doppler data in Spanish and Brazilian and Portuguese. And so if you need interpreters for your protocols, let her know. So she has some volunteer interpreters.
Nathaniel?
Yes.
Couple of things. One, gold is geostationary, so it's looking down.
Okay, that's great.
And then the other thing is, I just realized, there's a geomagnetic observatory or something, a lot of that activity in Peru. And Jim did his work down there, but that was a long time ago. I don't know if he might be able to put you in touch with people in Peru that would be interested in participating.
Yeah, I think that also sounds really good. So I think there's going to be a lot of people who want to be a part of this. I think, again, it's just figuring out what the best way to pull them in. What I would probably do is I would probably try to, get all of them. I'd probably try to get a team or a representative, try to identify someone who'd be kind of a South American.
Yeah, well, that's why I'm suggesting that they might be able to pull something together from the South American side.
Yeah. So I think that's great. Gary, what are your thoughts on this?
No, everything you've talked about made sense. I mean, there's if we've got people of interest and we've got the ability to translate some of this stuff, let's move. We've got a few months, so let's move on it.
Yes. All right, so that sounds, let's see, I think we're getting close to the top of the hour here. I need to print something for Francis, who just, I'd like everyone to congratulate Francis, who's about to defend his master's thesis on software engineering, looking at using, for developing the MSTID analysis code for SuperDarn. So everyone,
Nice to meet you guys.
Congratulations.
Yes,
Thank you.
good job.
Appreciate it.
so I have to get him a form. Anything else for today?
I owe you the list of exhibitor badges for the Hamfest. I've got that. I'm not sure what the deadline is, but I'm not getting any more additions to it. So how about if I just send you that?
That sounds really good. Yeah.
Gary, I don't know if I've gotten on the list yet. I wanted to be listed as an exhibitor.
Okay, David.
N1HAC.
Yeah,
Thanks.
I got you. Okay, no problem.
Yeah, I definitely need to reach out to them because I've got a whole stack of them that they printed out. And I know like I've got John Gibbons here, but I know John's not going to Dayton. So there's a whole bunch of people I know aren't going to Dayton I have in this hand. And there's ones that I think are going that are in this hand. So yeah, we got to get that straightened out. So all right. So I guess we'll see everyone at 4 today, or some people at 4.
Yep.
Great.
John,
Thank you so much.
John,
Yes.
apologies, and I know you got a full plate.